So we'll jump into it. So I think we have to start out with just a quick reminder of kind of the efficiency mapping process. So, we start with a test we need to run, and we have to ask ourselves, all right, I'm making an efficiency map. Is this map finished? If it's not, we move to the next torque and speed point. From there, with our dynamometer test stand, we need to set a torque and speed. We fix this torque and speed. We need to ask ourselves, are the conditions stable? Am I holding torque and speed? And we'll see an example of this a little later. If we're not, we need to wait, tick-tock, tick-tock, for that dyno to settle. If we are at a stable condition, we need to ask ourselves, are we in the temperature range that we want to test for? So again, we're waiting for that temperature to settle because machines are heating up while they're settling. Machines need to be cooled down. Next step, if we're not in the temperature range, we need to cool down. If we are in the temperature range, we take a measurement. From there, we have to ask ourselves, is this measurement good? So we actually have quite the process of stable torque and speed, stable temperature. Is the measurement good? And we have to do this for as many points as we have in an efficiency map, which sometimes is 100, 200, or more. But we're not just running one map typically, especially for control and calibration purposes. We have a whole list of conditions that we need to test for. Different temperatures, different flux states, different gears, different battery voltages. So we have to ask ourselves, once I've finished one map, have I finished all the maps? And if not, I need to move to the next test condition and run a new map. So we have all these points we need to take. Now we have all these maps. Oop, going the wrong direction. And at the end of the day, we're validating an engineering decision. So we have to go through all our engineering decisions for all of our different maps, for all of our different set points. And this can end up adding up pretty significantly. And we always have to remember that these tests can stop at any point. Somebody opens the test cell, everything shuts down. So, okay, we kind of have this complex thing where we're going from point to point creating this efficiency map. And we have to do a lot of points. Well, how many points are we talking? And again, I'm kind of setting up the problem statement. Well, let's say an efficiency map we're running, our little matrix of torques and speeds where we want to measure all the different torques for a given speed. And we want to go through set torque, set speed, take measurement. So let's say we have 10 temperatures and we have 5 saturations or fluxes that we're looking at. We want to test 5 states of charge, kind of our battery voltage. Well, okay, if each map is 200 points, we need 200 times 10 temperatures times 5 saturations times 5 states of charge. We're at a 50,000 point map. How long does a 50,000 point map take to run? Well, if each measurement point is 10 seconds, that's 139 hours. That's the better part of a week. If we have a 1 second measurement, we're at 13.9 hours. And if we have a 0.1 second measurement, and this is including just measurement speed, not those transitions, not heating up, cooling down, not user errors, 1.39 hours. So there's a pretty drastic difference. Now, with traditional equipment, a lot of people are running 10-second measurements, so they'll reduce the number of points. And I just kind of have my chart here. If you only do 20K points, all right, 55 hours, 5.6 hours, 0.56 hours. 5K points, now you're in kind of this reasonable range, this 1 week range, but you still have heating up, you still have cooling down, you still have other tests to run, you have those transitions of the dyno, plus sometimes Johnny the intern wires something backwards and you have to rerun a test, or you set up a torque offset back incorrectly, so you have to rerun a test. So the point I'm trying to make here is that these things can take a lot of time. So how can HBK help you speed this up? Because we really want to be in this range. If we can get you from 10 seconds to 1 second per measurement, we're saving a ton of time. I mean,